Hello there. So I've written up some chapter 4 review problems for you. This is just going to be a quick little review of the concept of chapter 4. Of course, to be ready for the chapter 4 test, I encourage you to look at your note sheets and study your book and your homework and ask me any questions you have about any of this. And of course, view the videos that I put on Schoology and or on YouTube. So, all right. So this is going to go through the main skills you need in order to do well at chapter 4. And we're going to chat about the vocabulary. There's really 4 main skills you have to have. You have to be able to say how you're going to randomly select one group from another. You have to be able to describe a bias situation. You have to be able to describe a confounded situation, and you have to be able to design an experiment. And then aside from that, you have to understand the terminology. So here's the first skill. It says this. It says there are 2,400 students at Riverdale High School. A study is being done to estimate the math aptitude of these students. And SRS, or simple random sample of 100 of these students, is taken. Describe how to take the simple random sample. If you want to pause the video and try to do this, that would be good. Or if you just want to kind of pay attention or whatever, that's fine. So we got to do 3 things. All right, you got to do this. You got to give each of the 2,400 students a unique integer from 1 to 2,400. You have to say it like that. Okay, you could say distinct integer or integer ignoring repeats. Okay, step 2, use a random number generator to create 100 unique integers from 1 to 2,400. And then you need to sneeze. Okay, great. And so then, all right, and so then it is the students with these 100 integers that are in the sample. You got to say it pretty much just like this. Don't leave out the 1 to 2,400. Okay, say it like that, and that would be good. Or you could use the hat method. The hat method would be to write the names of the 2,400 students on 2,400 pieces of paper that are the same size and well mixed. Pull out 100 pieces of paper, the students whose names are on those 100 pieces of paper in the sample. All right, so that's how you take a simple random sample. So let's see what question or part B has. It says the 2,400 students of Riverdale all went to one of 2 middle schools, Central Middle School and Valley Middle School. 1,000 of them went to Central and 1,400 went to Valley. It is thought that the students that went to Central will score differently on the math aptitude test than those that went to Valley. Describe a sampling method that can be done to reduce variability. What can be done to reduce variability in your results is 1 of 2 things. Either a bigger sample size, which is not an option here because it says we're going with 100. All right. Or to properly stratify. Remember, stratified sampling is when you divide into groups and take some from every group. And so you would do that if your groups are different. If your groups look like that, all these groups are different. You would say, I need to get some from every group. And the result of doing that would be less variability, more precise results. And now in this case, the other thing going on here is you want to do it proportionally. You know, in the population, 1,000 of the 2,400 are from Central and 1,400 are from Valley. So what I did here is I found the percent, 1,000 of the 2,400, about 41.7% went to Central. So that means in my sample of 100, I would take 42 students because that would be about 41.417 times 100. So I'll take 42 students from Central and the rest from Valley. You had about 58% of the population that's from Valley. So I'll take 58% of the sample from Valley. So that would be 58 students out of the 100. And so then what you would do to describe a stratified random sample, write the names of the 1,000 students from Central on 1,000 pieces of paper that are the same size and well mixed. Okay. Select 24 pieces of paper. The students whose names are on those 42 pieces are in the sample. In a similar fashion, randomly select 58 of the students from Valley. That's how you do a stratified random sample. And if you do it properly, in other words, if there really is a difference between Central and Valley, you'll have more precise results. It doesn't diminish bias. The randomness takes care of that. The stratification makes your responses more precise, less variable. Part C. As opposed to taking a random sample, the principal of the school decides to have the first 100 students who arrive at school one Friday to take the math aptitude test and use that as an estimate of the math aptitude of all 2,400 students. Describe the bias in this situation. When you're describing bias, you have to state how you think that your estimate will differ from the true value here. So, and so in this case, what you could say is this. the first 100 students who arrive at school may be more motivated than the other students. Maybe this increased motivation would lead to higher test scores than the student body as a whole. Thus, the sample mean obtained with these 100 students would be systematically too high of an estimate for the population mean. So I've stated which direction I think the estimate will be off. In this case, which direction the X bar will differ from the mu. So that's how you describe a biased situation, stating which direction you think the estimate will be off and why. So, and that's the second big skill you have to be able to do. All right, now, and so that's a summary of your stuff in 4.1. Of course, we still have to talk about the various vocabulary. All right, so this one's from 4.2. So this says a farmer claims that he has invented a spray that makes strawberry plants grow strawberries that are a deeper shade of red than normal. He notes that he used the spray this year and his strawberries ended up with a much deeper shade of red. So there seems to be pretty convincing evidence that this spray works in making the strawberries a deeper shade of red. But describe how the concept of confounded variables may be involved here. So confounded variables means we've got a situation here to where we appear to have this spray. So our explanatory variable is the spray or not, and it appears to be causing this situation with the strawberries being a deeper shade of red. And what a confounded variable, some other variable here is maybe connected with the spray, all right, that is actually causing the deeper red. So what I came up with, maybe it rained more this year. So there's more rain this year than there was last year. Maybe it is the increased rain that's causing the deeper shade of red. So even though it appears to be the spray. And what you make sure and remember to say is that the more rain occurred while they're using the spray, that connects these two variables. You have to write a phrase for each of these arrows. Okay, so this is the way I did that. So maybe there's another variable that caused the strawberries to be a deeper red and not the spray. All right, maybe during the time the spray was used, it rained more than normal. Maybe it was this increased rain that caused the deeper shade of red, even though it appeared to be caused by the spray. So I've made phrases for each of these three arrows. And so that is what we call a confounded situation. Confounded variables are two variables whose effect on a response cannot be distinguished one from the other. So we can't tell in this situation, was the deeper red, was it a result of the spray or was it a result of the more rain, and or how much of which influenced it? So we would say these two variables are confounded. All right, and so the answer to figuring out whether the spray works is to do a controlled experiment. So describe how you could do a study that would show whether or not the farmer's spray works as stated or not. And the way you do that is a controlled comparative experiment. So we're going to impose the treatment of the spray or no spray. So when you're doing a controlled experiment, you have to do these three things when you're designing one. Just like we talked about in our notes, you have to clearly state how you're going to randomly assign the units to the treatment groups or the treatment to the units. Clearly state what's happening in the groups, and then clearly state how your responses are compared. And so that's what I'm going to do right here. All right, so you obtain 100 strawberry plants for the student, which I just made up that number. Most of the time that'll be given to you in the problem, but it isn't here. Assign each of the 100 plants a unique integer from 1 to 100. So I've got to state how I'm going to randomly assign them to groups. So I give them all a unique integer from 1 to 100. Use a random number generator to create 50 unique integers from 1 to 100. The 50 plants with these integers will be treated with the farmer's spray while they're growing strawberries. So that's what we call our treatment group. They're getting the treatment. The other 50 are going to be the control. The other 50 will be the control group and will not receive the spray. So I've clearly stated how I've randomly assigned them to the two groups. And I've stated what's happening in those groups. They're getting the spray and they're not. Other than the spray, the 100 plants will be treated in an identical fashion. So, and that's important to keep any sort of bad things happening in our experiment. And then I've got to clearly state how I'm comparing results. After the strawberry growing season is over, compare the deepness of the shades of red of the strawberries that were from the spray group with those from the control group. So you compare the response between your two groups. So you have to say what your response is, the deepness of the red in this case between the spray and the control group. And that is what we call a controlled comparative experiment. Okay. Another aspect of experimental design is if blocking, if there's another variable that comes along that's not the spray, it's not the which is the explanatory variable, and it's not the redness of the strawberries, which is the response. If there's another variable that we want to take care of, we block it. So this says this: the farmer has 2 fields that he grows his strawberries on, one next to the river and the other next to the barns. We have another variable. Which field are they grown in? Under what circumstances would you create blocks in the experiment with the 2 fields being used as a block? The key thing, this is very similar to stratification. Remember, stratification, you stratify if there is a difference in the groups, and the result would be less variability. All right, blocking is a similar thing. You're going to create blocks if your groups are different, and it says the groups in that are next to the river, the group next to the river is different from the one next to the barn. All right. So anyway, or that's what would cause you to do it. He should create blocks like this if he has reason to believe that the 2 fields differ in regards to the relevant issue, in regards to how the color of the strawberries grow here. All right. This would result in less variability response. So that block, what that would mean is he would take both his blocks, both fields. He'd take the field next to the river, randomly assign half the plants to get the spray. The other half would be the control, which would get no spray, and do a full experiment with the plot next to the river, and then do a full experiment with the plot next to the barn. Okay. And that would be a block design. All right. And so, okay. So there you go. That's your little quick run through of the skills, the 4 skills. The other thing is you got to study this vocabulary. So this is from the 4.1 note sheets. You've got to study, you've got to understand these things, and you got to be able to pick them out of a context. Okay. So, and the best way to do that is to read examples like in your book or in your note sheets, and to be able to pick, stratified sampling, dividing into groups, taking some from each group, cluster sampling, divide into groups, and selecting one or a small number of groups, bias, systematically favoring certain outcomes. All of these things we talked about, you need to study these terms, understand these terms, and be able to identify the terms in a context. So this is 4.1, and that's sampling and surveys. And then the other one is 4.2, which is experimental design. So you need to understand these experimental design terms that we have talked about in class on more than one occasion. And like I said, you've got to be able to pick them out of a context. And so if you can do all that, you should be able to do really well on chapter 4. Well, that's it. That's my quick little run through, my quick little review of chapter 4. And if you have any questions about that, please contact me, and I'll be glad to chat with you.